Let's get started. Today we are going to look at derivatives and tangent line problems. So look at the picture here. There are two lines drawn. One is secant line and another one is tangent line. So let's look at the definition of slope of the secant line if we are given 2 points. So look at this picture. There are 2 points here and there. So if you want to find the slope of this line, we all know slope is nothing but rise over run. So the height is the difference between y coordinate of these 2 points. So it's going to be f of c plus delta x, then subtract the y coordinate of this will give you the height, right? In other words, rise is the difference of the function over the x difference is nothing but the run is nothing but delta x. So this is the definition. This is coming from our high school, right? The slope, formula. Now, how can I use this slope formula to find the limiting slope value of the secant line? So that is called the tangent line then. So if f is defined on an open interval containing c, so the limiting value of the secant line is given by this expression. Okay, so the limiting value of the secant line is nothing but the tangent line we call. Okay, tangent line of that point you are interested. So we consider the point C on the curve. Therefore, this definition will give you the slope of a tangent line. Tangent line is nothing but touching and going with the curve. So you could think of this is like a c comma f of c, x and y coordinate. Okay, so in that way, so you could think of the limiting value of the secant line, which is given by this formula. Okay, so that is the slope of the tangent line. Okay, so this picture will tell you everything, how it goes. Remember, limit delta x goes to 0 of delta y over delta x. That is, you see here, that's nothing but the limit delta x goes to 0 of f of c plus delta x, subtract f of function value at c, all over delta x. This is the definition you have to keep in mind if you want to find slope of the tangent line at the given point, c comma f of c. So this is a point, c is x coordinate and f of c is the function value y coordinate. Okay, so remember this formula. So we already studied limit in chapter 1, right? So limit could approach to 0 either in left or right. So that's why you see here 2 pictures. This one, delta x going from the left, this is going from the right. Still, if it is limit axis, then you should have the same answer. So ultimately, the secant line is going to be a tangent line, right? After finding the limit. Okay, so this is the geometrical expression or explanation about derivatives, limiting functions in other words. Okay, the slope of the tangent line. Now, question: use the above definition, that means this definition, to find the slope of the given function f(x), which is 2x minus 1, at the given point c is now 2. Okay, this is the given point. Remember, this is nothing but the x value. Okay, the domain. So the question is finding slope. So you could use this formula, right? This is the formula we use for the slope. So this is nothing but the slope of the tangent line, m. Okay, slope of the tangent line. Let us call this as m. So I'm using this formula to find the limiting value of this secant line. Okay, you know the function now, right? So let's do that. So if you do that, so I'm doing this problem somewhere here. Okay, example 1. So function fx is 2x minus 1, and the point C is now 2. The question is what? Finding the slope. So I'm using the formula. Slope is given by limit delta x goes to 0 of function c plus delta x subtract f of c over delta x. I'm using this formula, okay? Now you know function, right? You know the c value. C is 2. So I'm simply plugging 2 for c, and I'm rewriting this function. This is nothing but 2 plus delta x subtract f of 2 over delta x. Now your task is to evaluate this limit. Okay, so let us find first f of 2 plus delta x. How do you find this value? Simply take the function, plugging this guy 2 plus delta x in place of x. So you will get simply this is 2 times. Now x is going to be this all, okay? This all now you have the x. So 2 times, sorry, 2 plus delta x, okay? Then I'm subtracting 1. This is f of 2 plus delta x. Okay, so if you want, you could simplify this. This is 2 times 2 is 4, simply distribute inside, plus 2 times delta x subtract 1. So this is 4 minus 1 is 3, plus 2 delta x. Now, this is the answer I see for f of 2 plus delta x. Okay, that is there. Leave it. Now let us find f of 2. I need those two guys, right? F of 2 plus delta x, and I need f of 2 as well. Now I am evaluating f of 2. F of 2 nothing but take the f function, plugging 2 there, which is 2 times 2 plus 1. That is simply 5, right? So 2 times 2 is 4, 4 minus 1 is 3. So f of 2 is 3. So simply plugging those values here. So I'm going to rewrite this. F of delta x goes to 0. F of 2 plus x, just now we got the answer, which is 3 plus 2 times delta x. Then subtract f of 2. F of 2 is nothing but 3. This all over, I have delta x. Okay, now you need to simplify this. This is limit delta x goes to 0. If you simplify this, 3 and 3 gone. So you will simply get 2 times delta x in numerator. This all divided by delta x. Now if you simplify, these two are gone because using multiply sign. Now answer is simply limit delta x goes to 0 of 2. 2 is a constant function. We already studied, the properties of limits. If you have constant function inside, the limit answer is always going to be that constant. Okay, that means, we found the slope of the, tangent line at the given point 2. Remember, yes, we are correct. This is nothing but a straight line, right? The slope of the straight line here is 2. That's why you got the answer. For this straight line, slope is always fixed 2. Wherever you get the point, there, the tangent slope is always going to be 2 because of the constant value there you see. That's why you got 2 here, okay? Okay, correct answer. So, if you are asked to find the tangent line, or slope of the tangent line for the given function at the given point, if they ask you to use the definition, that means you have to use this definition, okay? This is the definition you have to use. And you have to use the limit definition and find the limiting value, okay? That is there. Now let's move on to find the definition of a derivative of a function. The derivative of a function f at any point x is simply given by this formula. Remember earlier we found the slope of the tangent line at the point C is given by this formula. Now instead of C, you are finding the slope at any point given x. So that is nothing but the derivative of function f at the given point x is simply denoted by this notation we use, f like apostrophe x. So in math, we read this as f prime. Okay, so we use this notation to denote the derivative of function f at the given point x. So you have to read like f prime x. Okay, so the derivative of function f at the given point x is simply the limiting value of fx plus delta x subtract fx over x. Use this definition if you are asked to find what? Derivatives, right? This is definition of derivative. So this is definition of tangent line. So make sure that you understand that. So f prime x is given by this limiting function, okay? Provided limit x is, this is true only if you get good limit answer. Otherwise, you have to say that the derivative does not exist if you do not find any good number for the limit. What is the geometrical interpretation of derivatives? The geometric interpretation of f prime at the given point C is nothing but the slope of the tangent line. Just now we saw, right? So we use another notation, which is nothing but actually m. Okay. So this definition is, we could think of another definition of slope of the tangent line. Okay. For the function f at the given point, we denote by f prime c. Okay. F prime c. The physical interpretation is nothing but the instantaneous rate of change of function f at c. Okay, we will do a couple of problems, for physical interpretation later. So what are the notations you could use for derivatives of functions? There are plenty of notations. Okay, suppose if you are given function fx, then you could use either f prime x or dfx over dx. You could use either notation, to denote the derivatives of function f. Okay, so you could use either one, f prime or d over dx of fx. If you are given function like say y is equal fx, then instead of f prime x, if you want, you could use y prime as well, because both of them are equal, right? Or you could write dy over dx. So there are so many ways now you could write the derivative function, right? There are 4 ways. If you see y in the formula instead of fx, you could use y prime instead of f prime, or dy over dx for df over dx. So that's up to you. If you do not see y in your expression, then don't use y prime. Simply you could use these two. Okay, now look at this problem. I don't see y here, right? Therefore, you could write f prime as a derivative of this function. Okay, so the question, use the above definition to find the derivative of function this. They're asking you to use the definition. So I'm going to use the derivative definition for the function f. Remember the definition. The derivative of any function f is given by f prime x. This is nothing but limit delta x goes to 0 of f of x plus delta x, then subtract fx over delta x. So you have to remember this formula, okay? Now I'm going to use this formula like earlier we did for the slope of the tangent, the same procedure. So I'm going to find now 2 things, f of x plus delta x, then subtract them, simplify, and find the limit. Let us do that. First of all, I need to find f of x plus delta x. You know fx, right? It is given here. Use this to find f of x plus delta x, then you have more work now. So f of x plus delta x, nothing but plugging x plus delta x for x here. So you will get f of x plus delta x as, and replacing x by this all. It's going to be x plus delta x whole thing squared. That's my x now. Then plus 2 times x. X is now everything, right? X plus delta x. Then subtract 1. Now you have to simplify this, okay? So remember you learned in school, how do you expand this? Would you expand x plus delta x whole thing squared? So for that, remember the formula you learned in high school. Any number a plus b whole thing squared is given by a squared plus 2ab plus b squared, right? I'm using this expression formula. Now here a is x. This is, you could think of x as a. You could think of delta x as b. So I'm using this formula, okay, complete square formula. So if you use this formula, a is squared, so that is x squared plus 2 times ab, right? Now a is x, b is delta x. Then plus b squared, right? Plus b is now delta x. So you have to put delta x squared. Then you have to simplify this part as well. Distribute 2 inside, so you will get plus 2x, plus into plus plus, 2 times delta x is plus 2 delta x. Then subtract negative 1, subtract 1. Now you need to simplify this further. This guy is there, x squared. Okay, so here I see 2x delta x. Okay, let's do like this. I'm going to copy down this all. I'm going to copy down this all here. Okay, you are finding this limit, no? You are finding this limit. So I'm going to plug in this value here. Let's do that. So I'm going to plug in those. So this is going to be limit delta x goes to 0. F of x plus delta x answer just now we got this huge expression. Going to copy down that x squared plus 2x delta x plus delta x whole thing squared, then plus 2x plus 2 delta x, then subtract 1. So this all just for f of x plus delta x, okay? Then you need to subtract f of x, right? I know f of x. F of x is here, given in the problem, which is x squared plus 2x minus 1. This is just the numerator. This piece is all over. I have the denominator delta x. Now your task is to simplify the numerator, okay? So let us simplify the numerator then. So you need to distribute negative sign inside here. So you will get x squared plus 2x delta x plus, let me put the characters, delta x whole thing squared. Then you got 2x plus 2x, then plus 2 delta x. Then you got negative 1 minus 1, then minus x squared minus into plus again minus 2x, then minus into minus plus 1 plus 1. So you got that. Okay, so now you have to simplify this. Okay, could you simplify this? You have to simplify. Some terms are going to be cancelled. Okay, some terms are going to be cancelled. So what are those going to be cancelled? So let us simplify this. Okay, so this all over delta x is there, right? Now I'm going to simplify. Look at that. X squared, I'm using different colors. Okay, you see x squared will be cancelled with negative x squared. Okay, negative 2x and positive 2x gone. So it's 1 here. This one going to be cancelled. Okay, so you be careful when you simplify it. Going to be cancelled. Okay, that's it. So now you could write down the remaining term. Let us write down the remaining term then. Remaining terms are going to be limit delta x goes to 0. I see 2x delta x here, and I see plus delta x squared, that is here, and I see plus 2 times delta x. These are the 3 terms left over after simplifying. Okay, this all over, you see the delta x in the denominator, right? Now look at, if you look at the numerator, you could factor delta x out. Everywhere you see delta x, right? I'm factoring delta x out in the numerator. That means the leftover is 2x plus, I just pulled out only one delta x, right? So 1 is still there inside. Then plus, I already pulled out one delta x, so it will be simply 2. Now this all over delta x. Remember, you have multiplication sign here. So when you divide another delta x, this is still going to be cancelled. Now you could plug in the limiting value. When delta x goes to 0, this goes to 0, right? That is delta x. That means the leftover answer is going to be 2x plus 2. That is the derivative of given function, fx. Okay? Yes, we have more work now. This is called, finding the derivative of function f by using the definition. Always we have more work if you use, limit definition. So you have to do like this. Okay? So start with this formula. Start with this and find out f of x plus delta x like I did here, and simplify that. After that, subtract the actual function fx, then do some algebra to simplify and find the limit. Okay, that is there. Find f of x. Find f of x for the given function fx, x cubed. After finding the derivative function, then find the slope of the function f at the given point 1, 1. First of all, you need to find out f prime x, okay? Like now, like just we did. So you have to use like I did just now. So use that theorem or definition and find out f prime x, okay? You have to find the answer like this. So if you do like this by using the definition, you will get the answer. This is the answer I'm writing, okay? But you have to check, work like this, and check whether you are getting this answer for derivative fx for function x cubed. You should get 3x squared. And you have to check this. Please do this. Once you know the derivative function at any point x, what is the derivative? So slope means now we know, right? Slope of the graph of f at any point c is nothing but f prime c. They are asking you to find this guy. This is nothing but the slope, okay? But you know now the point c is given. C is 1. Okay? That means they are simply asking you to find the slope of f at the point 1. So you need to find then f prime 1. You have to find out what f prime 1 it is. So you know f prime x, right? This is f prime x, but you need f prime 1. Simply plug in 1 here. So if you plug in 1 here in your derivative answer, you will get the slope at 1, right? Therefore, f prime 1 is nothing but 3x squared, plug in 1 for x. That is simply 3. That means the slope of the function f at the given point 1 is nothing but 3. Okay, but anyway, you have to get first this. Okay, so you have to do this all hard work and find out f prime x. That's your work. Okay, do you have any questions? Anyone else here? There's one more formula to find slope at any point C, f prime C. Okay, that formula is given here. This is kind of shortcut formula, alternate formula to find the derivative of the function at the given point C. Okay, now you have two formulas, right? One is the very first formula we saw here. This is also the derivative formula for, the given point. This is another version. Okay, this is kind of short version. So you could use either one to find f prime c. So I prefer this one, is very easy. So limit now, instead of delta x, now you see simply x. No more delta x in this expression, right? That's why this formula is shortcut formula, we say. So it's very easy to calculate this. You will be given function fx, you will be given a point c, simply find this guy and find the limit. Okay, this is alternate form of derivative of f. Now there are a couple of things we have to observe here. Remember, you will find the function derivative f provided limit x is right, but there are some cases you will not find the limit. Look at this problem. If you look at point 2, if you try to find the slope or the limiting, value of the secant line, this is the line, right? You see, the slope is -1 from the right, sorry, +1 from the right, from this side. But if you try to find the slope at this point from the left side, but the slope of the left side is -1, you see two different slopes. If you see like these two different limiting slopes, then you all know, right? When you study limit, you have to have same answer from left and right, no? To have limit answer. But this says you are getting two different slope answers. That means it is not possible to find the derivative at 2. That's why it is here given, okay? F is not differentiable at 2 because the derivatives from the left and right are not equal, okay? These sort of, scenarios, appears when you have like sharp edges, like sharp turn. There you cannot find the derivative, okay? So your curve should be always smooth turn. Then only you will get, all the derivatives answer. So this is impossible. So if you see like this very sharp edges, there's no derivative. So you cannot find the derivative at that sharp edges, okay? So now this problem is another one. So what is you are given a function, okay? If you try to graph this function, it is here, okay? Question is, it is very clear, function is very much, smooth and continuous. But what will happen if you try to find the derivative or slope at 0? The tangent line at 0 to this curve is nothing but a vertical line, right? This line itself. We all know the vertical line slope is always undefined, right? We all know that. High school studies, the slope of the vertical line, slope of a vertical line, always undefined. We don't know. Does not exist. That's why we cannot find the limiting value of that secant line at this point 0. So it is not possible to find. That's what it says. F is not differentiable at x0 because f has the vertical tangent. So there's no limit. So these are the two scenarios you have to keep in mind when you find the derivative. Always you should get some limit answer, right? Otherwise it is not defined. So there's a theorem. If f is differentiable at one point, then the function f should be continuous at that point. Okay, so if it is differentiable, then function should be continuous, not the converse. Okay, not the converse. all the continuous functions are not differentiable, whereas all the differentiable functions are continuous. Look at this case. These two cases you could think of. These two graphs are continuous graphs, right? But still it is not differentiable at the first graph is at 2, not differentiable, and the second one at 0, not differentiable, even though they are continuous, right? So these two are what? Coming under the second case. Okay? Continuous function may not be differentiable, but differentiable functions are always continuous. Keep in mind that here, okay? Then you could look at the textbook and do the problem. So I'm going to assign some problem here from your textbook, okay, ebook. Why don't you try problem number 14? I will post the answer maybe later this week, but you have to try, okay? Problem number 14. You have to try this from your textbook. From your text, online textbook, okay? Go to web design. Go to web design and check the ebook. And find the problem number 14 under chapter 2.1. Try to do this problem and check my answer later, okay? So that's, I'm giving you one more problem. Problem number 27. Let's do this also. Okay, so this is all about chapter 2.1 sections. Finding slope of the tangent line by using limit formula, and also finding the function's derivative at prime x, by using again the limit definition. So make sure that you understand those two. Okay, let's move on to 2.2. Okay, 2.2. Now we are going to, use some basic rules for the differentiation of derivatives. Okay, these are like formulas you could think of. Okay, and here I have given as pair. The first easy derivatives rule or differentiation rules. The derivative of constant function, if you are given a constant function, you could think of this the given function f(x), okay, but that is constant now. If you take the derivative of any constant function with respect to x variable, answer is always 0. Keep in mind that point. So derivative of constant function, always 0. If you see inside constant, fixed number, answer is 0. Okay? Reason is here, any constant function could be drawn like a horizontal line. You all know the slope of horizontal line is 0. That's why derivative also 0. Derivative means now slope, right? That's going to be 0. Second rule, power rule. The derivative of any power function, if you see the function x variable and the power, constant power n, then this is nothing but n times xn minus 1. Okay, for example, think about this. If I ask you, hey, what is the derivative of x squared? Would you compare this function to the formula? What is n here? If you compare the formula, instead of n now, I see 2. N is 2. So use this formula, plugging 2 there. So you will get d over dx of x2 is nothing but replace n by 2. So could you simplify this? 2 minus 1 is 1, right? The answer is 2 times x to the power 1. X to the power 1 means simply x. Means the derivative of x squared is nothing but 2x. So n is the fixed number. You could have any real number, constant number there. Okay, so that is power rule of differentiation. Now there are some easy problems, examples. Find the derivatives of the following. First one, the given function is 2 pi. Remember, pi is a constant number, 3.142. Altogether, this is a constant. Therefore, the derivative of this function is always 0 because of constant. Now, instead of fx, the function y is given. Therefore, if you take the derivative of function y, we write as pi prime. Again, this is also going to be 0 because the given function is 3 times k. K is constant, so 3k also going to be constant. So the derivative of constant is again going to be 0. But here, use the power rule. N is now 4, right? So if you use the power rule, now you see the function g. So if you take the derivative, you will get g prime. Okay. So g prime is nothing but I am replacing n by 4. So you will get 4 times x 4 minus 1. Which formula I am using? I am using g prime x is equal n times xn minus 1 formula. Derivative of g function is now exponential or power function. Okay, using this formula. So n is 4 here. This is n. So if you simplify, you will get simply 4 times. You will get simply 4 times. This is 4 times x to the 4 minus 1 is 3. Okay. The last one, what's the derivative of 1 over x? Remember, 1 over x could be written as x to the power negative 1. Remember, using exponential property you learned in high school. Now here n is negative 1. This is going to be n. So if I use the power rule, y prime is nothing but negative 1 x negative 1 minus 1. Here n is negative 1. Okay, remember. N could be even any number, no problem. So if you simplify this, what you will get? Negative 1 times x to the negative 2. If you want to write, exponent as a positive, this is nothing but negative 1 over x squared. So, right? So I use this property. We call the high school work. You learn, exponential properties. 1 over x to the power m could be written as x to the power negative m using this property. Okay? Get here. Get here. So make use of that. The last problem. Find the equation of the tangent line to the graph of fx when x is negative 1. Okay? So you are given a graph now like this. There's a point 1 here. The question is, could you find the tangent line equation? There's a line going like that, right? Straight line. Your task is now finding the equation of this line. We don't know. But the point is given now. This point is negative 1. X value is negative 1. Okay? If you're plugging x is negative 1, you will get the y value, which is negative 1 squared, which is 1. This is the point we are looking for. Finding the slope of this line and the equation. Okay, how do you find the equation of the straight line? If you know a point, again recall high school work. Straight line equation is given by y minus y1 equal slope times x minus x1. I'm using this formula to find the tangent line equation. Okay, remember tangent line also a line, right? So if you are asked to find the equation of the tangent line, simply use this formula. X1 is negative 1, y1 is 1. So you know x1 and y1. Okay. So this is x1. This point is y1. You know x1, y1. Your task is first finding the slope of the tangent line. You know now, slope of function f is nothing but f prime x, right? So let us find the slope then. You know the function fx. Fx function is given x squared. Now you know how to find the derivative function fx. This is exponential, right? N is 2. Therefore, f prime x is 2x 2 minus 1, which is 2 times x. That is the derivative function at x. But I need now derivative function at 1, right? Hold on, negative 1. Now your x, right? You are finding the slope at negative 1. Therefore, the slope m of the tangent line at negative 1 is nothing but f prime of negative 1. How do you find this guy? You know f prime of x. F prime of x is 2x. I need f prime of negative 1. So simply plugging negative 1 for x in this answer, okay? So that is negative 2. That means the slope of the tangent line at negative 1 is simply negative 2. Now, that's it. Use this formula for the equation. I'm using that formula. Y minus y1. Y1 is 1. Slope of the line just now we got negative 2. X minus x1 is the point where given, which is negative 1. That's it. Now, if you want, you could simplify this expression. Negative 2 times x is negative 2x. Minus into minus plus 1 inside. So when you distribute between negative 2, negative 2. Then I am subtracting 1 and I am rearranging into y is equal mx plus b form. So if you do that, y is equal negative 2x minus 1. This is going to be the equation of what? This is the equation of the tangent line at the given point, negative 1, 1. So this is the way to find, okay? Tangent line. First find the slope by using the derivative formula, then plugging the x values into that formula to find the slope, then use y minus y1 formula. You learn it, to find the straight line. Okay? There. So now you could think of this all the work. Before that, that's one more property. If you have constant multiple with the function, there's a function fx, but you see the multiples, constant numbers here. If you see some constant numbers times the function, the derivative of that guy is nothing but the constant times the function derivative. Okay? So this is like, look at that. Example A. This is a given function, right? 5 times x cubed. 5 is constant, so you could simply keep 5 out and simply find the derivative of the remaining x cubed. You know how to find the derivative of x cubed using power rule. Will give you 3 times x squared. After that, simplify it, you will get this. Okay? Now your task is to go through these answers and make sure that you understand these all. And if you have any question, just tell me next time. Okay? So I will go through one more time. Next, another theorem. If you are given two functions, so you are adding or subtracting two functions, then what will be the derivative of the resultant function? Well, you could find the derivative separately and add them. So finding the derivative of sum is nothing but the sum of the derivatives of the given function. Similar thing can be applied for subtraction also. The difference of the derivative of the functions are nothing but the derivative difference. Okay, that is there. So make sure these two rules. So why this is important? Suppose if you are given like this very big function, then always easy if you apply that some rule or difference rule. Simply find the derivative one by one to each term. Okay, then you will get that. You see the work here. Finding the derivative of this huge function is nothing but finding the derivative individually one by one. Okay, like that. It's very easy to observe, right? Only thing is here they are using what? The constant differentiation rule and the power rule. Okay, Again, question may be like this as well. So you have to make use of some knowledge, of algebra you learned. So you could split the given, you know, expressions into individual fractions. After that, just use power rule individually for each term to find the derivative. Okay, it is there. Now let's move on to the trigonometric function derivative. If you are given sine function, the derivative of sine function is always cosine function. The derivative of cosine function is negative sine function, sine x. Okay, so now you could use those properties to find the derivative of trigonometric function. Look at the first one. What is the derivative of 2 times sine x? So the given function was, y function was 2 times sine x, right? Remember 2 is the constant, you could think of sine x as a function fx. So I'm using that constant multiple rule. So the derivative y prime is given by 2 times of the derivative of the function fx, which is sine x. You know now the derivative of sine x is cosine x. That's why answer is 2 times cosine x. Okay. Look at the second one. Sine x over 2 could be written as half times sine x. In other words, if you see any denominator, you could pull and write first, then multiply with the function. Now 1/2 is the constant. Keep 1/2 as a constant and simply take the derivative of sine, again cosine. Okay. The third one, you see now two functions. So you have to use the sum rule. Find the derivative separately. The derivative of x is 1. The derivative of cosine x is negative sine x. Here, use that, and so on. Okay, so make sure that you understand this also. Now this problem is just to think about, um, you know, the instantaneous velocity. The velocity function of any object is nothing but ds over dt, where s is the position. If you know the position of the object, always it is possible for you to find the derivative of that position function, which will give you the velocity function, right? So this formula you could use to find the velocity if you know the distance or displacement or position functions. So you could think of what problem? Let me think. So why don't you try from your textbook? Okay, from your textbook, problem number 25 from chapter 2.2. Try this problem. Okay, anyway, I will give you answer. And problem 58 and the problem. It's just to practice, okay? You don't need to turn in. Simply practice them. I will write the answer and upload my answers maybe later this week. But you need to try, okay? You need to get the answer first. So these are the two sections today I'm covering. So make use of time to learn these two this week, and let's see how it goes. Okay. If there's any question, you can ask me. Otherwise, okay, you.